Hey everybody, this is Luke Parisi with the weekly Devblog on the 3D engine I've been working on. This week I've focused on oriented boundary boxes and getting the camera look system correct. So I started with OBBs, and as I was learning that I realized some stuff about the camera system I had in place and improved upon that and converted that to a yaw pitch roll system, except I'm not using roll because it's an FPS, so you don't really need roll. But that's now working correctly, and I've got OBB oriented boundary boxes and oriented boundary box collision detection in, as well as axis aligned bounding box collisions. But these videos I'm going to make a bit more of a tutorial as well for anyone interested in how this all happens, and I can explain a bit more. But I'll start off showing this stuff off and then I'll go into the code. So I'll start with these ones here. So I think from last week I didn't have the collision detection on the models itself, I just had it on the y equals 0 or y equals 2. So now I've implemented these. So these models here, which don't rotate, they have a collision box which is axis aligned, and they're less performance heavy to calculate. So if the object isn't rotating, then I'm just doing those calculations there, and as you can see, if I fall off the edge here, so that's based on the model collision box, and that's simply the min and max values, which I did have implemented last week. Now that I remember the min and max, I just didn't add the collision for it yet. So as well, I've added translations along the 3 axes. I don't know whether this one, so this one's just moving along the, I think the X or the Z axis here. That one there is moving up the Y there, and then the other one is moving in that direction. So this translation this is still using the AABB collision box, and that updates it so I can fall off the edge here. And then as you see here, if it translates off, I'll fall off the edge there. So that's updating the collision box based on the translation there. So I'll start with rotations. I'll start with this object here. So this is rotating on all 3 axes, and I've put these models in here to see where the corners are, because when I first started implementing this, the matrix translation I was applying was incorrect, and it was just because I was doing matrix transform along the pitch yaw roll. Instead, when the model was creating a translation along the 3 rotations. So then I just changed it to use the same translation there, and it's putting the collision box in the same position. So as you see here, this one's a bit hard to show. I've added that dash as well. It's a bit hard to show off the collision box a bit. So I'll do it on this one. And I've only done it from the top. So as you see there, if I look this way, it might be better to see. So if I'm here and it's rotating downward, I'll fall down along with that. Same again. So there, when it rotates from under me, I'll fall. Same with down here. So if I stand on this corner and it rotates away from me, I'll fall. So that shows that the collision box, well, the oriented bounding box collision detection is rotating correctly. I've got one that's rotating and translating, so that's working as well, but I'm not going to go all that way over there just to show that is a runaway plane there. So here I've got them rotating on 2 separate axes, this one, and this one. So I think that one's XY, this one's YZ, this one's XZ or something. I can't remember which one's which. And this one's rotating on all 3. So there, you'll see I collide until I fall under. And I've still got to do the collision from the left and right, so you can actually move through it. If I do that, see, I can move through it, because I haven't implemented that collision yet. I've just implemented it from the top with gravity. So, but that's fairly straightforward to expand on, especially translations. If I'm colliding with it and it's moving upward, I want it to move the player bounds upward as well with it, or along the X or the Y, and I haven't done that yet, as you saw. Same with the rotation. So if I'm standing on this, it's not moving my position, but I do want to add that functionality so that it moves your position. So I was really happy to implement oriented bounding boxes. That was something new to me. And even in Battle Court, my 2D game, I had collision boxes, but the sprites themselves were rotating, but the collision box of those sprites didn't have any rotation because I was using rectangles and they're axis aligned. So I'm not sure if it's oriented bounding boxes or oriented rects in a 2D environment, but it wasn't necessary really. Like if I had the bullet fire at a certain angle and hit the enemy, I just had the bounding box a bit smaller than the sprite itself, and then it was fine anyway. And for anyone who's played Battle Court, you might not have even noticed it's a bounding box. But yeah, so I didn't add, there was no rotation in the collision detection in that game at all. But to now move into a 3D environment and implement rotating bounding boxes, oriented bounding boxes, I'm really happy with that. So yeah, I spent a lot of time on that. Same with the look system. So if you recall the last week's video, I had it rotating around, so the circle it would calculate, right? And then I just had a kind of like a column up and down. But now I've added proper yaw pitch roll camera functionality. And I'll quickly show this as well, which is so this is going to be turned into the bullet firing system. So at the moment I've just have it creating 3D models at where you're looking, and the model itself rotates equivalent to your rotation. So instead of models, this is going to be raised, and they won't be creating. So if you see in the text there under pitch, you'll see bullets 2000. So it's creating one model per frame, and that's because I just haven't added a firing rate limit there. So you'll see, yeah, it's creating all this. So that'll be raised, and it won't be creating them as rapidly. And so you can see it creates a sphere around you. I thought that was pretty cool. But yeah, the rotation remains correct to the rotation you're looking. So if you're looking upward, so when I implement raise, it's pretty easy. I'm using that exact same rotation vector there. So that's some of the stuff I've implemented this week. I'll go through the code now if I switch to desktop mode. So I'll start with the code with the camera, because this was the first thing I implemented this week. So I started learning about oriented bounding boxes, and then as I was learning, I realized the stuff of the camera, and then started implementing that, and then I went back to OBBs. So the camera here, I've now created a camera class instead of doing it all in player. So in camera class, I've got three methods. One for the yaw, which is looking left and right. One for the translate, which is when you move with WASD or whatever. So that just moves your cam position and target in your translation vector. And the translation vector is calculated still in player. And then pitch camera, which is you're looking up and down. So with pitch, when I first implemented that, and I'll comment this out, I was getting gimbal lock, and And I think anyone who has worked on a 3D engine and built a camera system might have come across Gimbal Lock in some way. For me, I'm getting it on pitch, and I understand why I'm getting Gimbal Lock, and that's because I'm using vector 3s in cam position and target, and then using them to calculate the angle. So that angle, because it's based on vector 3s, it gets Gimbal Lock, and I can't remember exactly what it's called, but it's a problem in Euler, using Euler physics or something. But if the calculations were matrices or quadrons, I think I'm saying that right, then Gimbal Lock shouldn't occur. But when I implemented all this stuff, I was still learning. Same with cam target, cam position, because this has all been a new thing for me. I was using vector 3s, and I didn't want to change it all at this point because I still am not sure how I would go about it. So for now, what I've done is I've done this kind of hacky way to resolve that issue. So that's this code here. So I've commented it out at the moment. Now with it commented out, I'll show you. I'll just switch back to scene so it doesn't lag. There we go. So this, I've commented out my Gimbal Lock Fix. So if I move here so you can see it and I don't fall off the edge. So you see that? What I'm doing here is I'm looking downward. It's the same when I look up, but you won't be able to visualize. But if you see here, I've got in the top there my view matrix vectors. So my right, up and forward. If you look at forward, when Gimbal Lock occurs, it's I would say inverting. I'm not sure if that's the right terminology, but it's flipping that forward vector. It's flipping the right a bit as well. Yeah, it's flipping it the right, and the up stays. And that's because when I'm looking down, I'm directly along the y-axis, and when I try to look further down, the calculation from cam position to cam target is now, I guess the best way is to say it is it's behind the y-axis. So here I'm kind of from here to upward. I'm still, I would say, I'm in front of the y-axis, even if I'm looking here. It's all proper, but if I'm looking now directly down, where I'm looking directly along the y-axis, if I go further back, then it'll flip because it must think it's behind it or something. And yeah, that's that Gimbal Lock. And then it'll just keep, if I keep trying to scroll down, it'll keep inverting and inverting. So half the time it's inverted, half the time it isn't. So that's the Gimbal Lock. Now, what I've done to resolve it is kind of hacky. I mean, ideally you don't want to you just don't use vector 3s, I guess. But because I've done this. So the idea behind it was before I apply the movement, I calculate I create a temp matrix before the translation itself. So that's this one here, and then here's pre. Actually, yeah, here I'm applying. So this temp matrix here, I'm applying the movement. So what I'm doing is, so I have the view matrix, and then I move the view matrix, and if the movement of the view matrix, if that creates the Gimbal Lock, then I just revert back to the matrix before it. So this pre-transform amount here. So here, it's this line here. yeah, here I'm applying the transform here. So what I'm doing here is I'm getting your angle before applying the transform. So here your pre-transform amount is what it was before, scrolling down, let's say. And then after I've got this pre-transform amount, I'm applying the transform to the cam target, and then I'm creating preview on the view matrix. So yeah, this is before view matrix has applied anything, and then I'm creating a lookout based on the new. So this is the new angle. So this has the gimbal lock here, but with these values here, it doesn't. So here, this has the gimbal lock because now I've created a lookout with those new values, cam position, cam target, and then with the gimbal lock, I'm now getting the X and Y of those there. So here I'm getting the X and Y before the gimbal lock is applied. Then I'm updating the view matrix and then getting the values, well, not updating the view matrix, but getting a matrix which has those updates and then getting those values there. So then with this diff X and diff Y, I'm just I'm minusing the previous from the current and comparing. So let's say gimbal lock didn't occur. This should just be like 0 point, or the little movement that you applied. But if gimbal lock did occur, you'll see the X, Y, and Z of the forward was flipping. So the change was greater than 1, let's say. Well, this is, I'm saying, if it's less than 0. So, well, here, yeah, this I'm just flipping the diff X because half the time if gimbal lock occurs, half the time that'll be like 2, almost 2. The other half it'll be -2. So I'm just flipping it. If it's -2, I'm just switching it back to be 2. Same with the Y. And then here I'm saying if the difference of those two matrices on the X and Y is greater than 0.5, then I know gimbal lock has occurred, and then I'm reverting the cam target back to the position it was before the movement. Otherwise, yeah. Well, I'm just applying rotation there as well. Otherwise, yeah, it then just uses the translation. So yeah, if gimbal lock occurred, revert back to the pre-transformed amount vector. So that's, I'll go back into the game to show you again. Start. Oh, work straight up. I didn't have to do anything. All right. So if I go over here, so as you saw before, the gimbal lock, but now if I look directly downward, I'm now scrolling down and it doesn't do it. So before it applies any update to your camera, I scroll down, it applies the update. Well, it creates a matrix with that new vector, and then that vector has gimbal lock on it, and then it's saying, all right, gimbal lock has occurred, revert back to the position you're in before. So then you will never see gimbal lock occur or anything. So it's the same with upward as well. So I would say it's kind of hacky, but it's good, it works. It's just a little bit extra calculation just because I'm not using matrices in the rotation, the camera rotation, and just because I'm using vector 3s. So that's that, and that's how I resolved gimbal lock for this. I'm not using this one yet, this method at all yet, but let's say you've got a cutscene or whatever, or if this is a third-person perspective game, you could use this set camera to always look at the position of your player object or whatever. And then here I'm just setting view matrix there. So this was, I can actually remove all this now, because this was the exact same gimbal lock prevention that I had up there, and I was doing it in the view before and after the view matrix calculation. But I didn't need to do that. I can just do that all before I cast to the view matrix. So that's the new camera system. So now I'll go into the oriented bounding boxes. So here, oriented bounding boxes is pretty straightforward. Actually, before I do that, I'll go back to player so I can remove those comments as well. But this was all the methods I was doing beforehand. So here, this was the old look up and down. So I was just getting a column in front of you based on your rotation as well, and limiting it to 60 frames upward and downward from your position. So that was the old look up and down. So now that that's gone, I can remove rotation pitch as well. And rotation, I'm using rotation yaw still, so that can remain in. I've moved this rotation to the yaw camera method there. So there was, before I implemented this system, there was a few ways I tried to approach it to resolve, but I couldn't get it working. One of the ways was, so here, as I said in the last video, I was using this yaw vector calculation, which is this is two-dimensional position calculation based on rotation. So I'm still using that because that's how I'm getting your forward vector. So that's still in. But as well, I tried to have two 2D circles to represent your one to represent your yaw, one to represent your pitch. And with these in, so when I had this functionality in, which was this here, two separate vector 2s, yaw and pitch, and here you could see I applied cam target as a new vector 3 with the yaw vector x and y to get your x and z axes, and your pitch vector x to calculate your pitch. And what was happening with this was left and right was working correctly, but your pitch was it was like a sine wave. It was, if I was continuously scrolling up, it would scroll up to a point, and then if I kept scrolling up, then it would start scrolling down, and then back and forward. It was just looking up and down continuously. So this one didn't work. I've just kept it in so that I could talk about it. So that was that functionality there. And then actually found a Wikipedia article about the proper 3D position calculation, which was your pitch and roll. And that's all this here. So this is the 3D equivalent of this. So this is the 2D circle calculation. This is a 3D sphere calculation. And I don't know what I got wrong, but that was scribbling all over the place. So that was incorrect. Ideally, this would have been nice, but yeah, it didn't work either. So that's that one. And this was the original one, 2D working. That was the original one. So now I have the camera system. So, and the camera itself handles your yaw, your pitch, and your translate. So it wasn't handling your movement forward based on the angle you're at, and that's where this one here, that's why this is still here, and that comes into play, which is, as you see here, when I translate camera, when I apply camera.translate camera, I'm passing in a vector 3 that's based on your as well. So your vector X, your Y is there, and your vector Y, which is your Z axis. Just multiply. This is actually when you double press. So multiplying it by 4,000 there, multiplying it by 10 here. And that was the old method as well there. So there you can see translate. So here, when I'm moving backward, I'm just moving back on the X, back on the Y. And then if I'm dashing, if I'm moving right, then negative Y here, X there. I can delete that as well. And delete that as well. So that's the movement, the camera movement and that. So now I can go on to OBBs. So oriented bounding box, this is the method. This is the class, sorry, I've implemented. It just has a position, rotation, and orientation, and your half widths, which is half of your width, height, and length. So to get all this working, I was trying to learn for ages, trying to figure this out, and then I came across this book, the Game Physics Cookbook, I think it's called, and it explained a lot of this stuff. Well, it explained OBBs and how to get collision working for OBBs, and that was a good resource, although that it was based more for C++, and what I found is a lot of the stuff they have in there it just was wrong. Like it didn't make sense what they were doing, but it gave enough information to figure out, you know, like for example, where is it? It's in collision. Like for example, this, when, actually not that, where is it? When I'm getting the matrix itself, yeah, here. So when I'm getting the axes of the oriented bounding box, so in these ones here, I'm getting the axes of the oriented bounding box that I'm to detect the collision on. And in the example that they gave, they were calculating, so they were creating an array of vectors based on the entire matrix, and the matrix they were getting was a 3x3, whereas the matrices in X and A are 4x4. So I had to actually go through the matrix itself. If I go to gameplay, so I was doing this, and I was writing to screen every single position in the matrix to see what M11 was, what blah blah blah, because I needed to know which ones I needed to cast through the which ones I needed to cast to the OBB. So these three vertices here, I needed to figure out, alright, this vertex needs to be M11, M12, and then I realized all they're really doing is getting the right up and forward vectors. So yeah, anyway, that was all that. So this is the collision class now, and what I'm doing based on that book and based on my experience now, I've got to get interval. So all this is getting the min and max of the object, right? This is, I guess, the projection of the 3D object on the plane that you want it to be. So here it's getting the interval of the object that's axis aligned. Here it's getting the interval of the object that's oriented. So here, as you see, it returns a result which is the min and max of the projection of that object. So let's say the OBB is rotated a bit, then we just get the projection along. So it's kind of like, if you, it's easier if I just draw, bring up paint. So here, let's do it in 2D, right? Here you have a rectangle. Let's imagine that's a rectangle. And here you have that rectangle's axes, right? So this is the axes of that. So let's say this is the X of that object. Geez, okay. That's an X, all right? So, and this is the Y. So they're the axes of that rotated object. Now let's say you want to detect a collision on this object here, which is axis aligned. So this is the game axis itself, which is X and Y. So what you need to do to detect a collision is you need to, let's just extend this. So you need to get the projection of this rotated object on the axis of the other object you want to detect against. So you're casting a projection there, you're casting projection here, right? And then you do the same for this object. So there's the So these are the projections of the two objects. So on the x-axis of the first object, well, of the axis aligned object, this object is creating a projection from here to here, right? This axis aligned object is creating a projection on this axis from here to here. So this little section here is colliding from here to here. And then the same here, right? This is creating a projection from here to here. And this object is creating a projection from here to here. So there's a collision here as well. So now that's two collisions detected on the first axis. But now we have to do the exact same on the axes of the rotated object. So here we cast the projection onto this axis here of this object, which is from here to here. So that's that projection. This one's casting a projection from here to here. And this axis continues on. So as you see along this rotated object's y-axis, there's no collision, there's a gap here. So because there's a gap, there's not a collision. So that's what this code is doing here. It's getting the projections along each axis. So if there is a gap along any of those projections, like here, there's a gap, we know there's not a collision. So no collision occurred. But let's say we've done all the calculations along all the axes. So with 3 dimensions, that's the three axes for both. Then if all of them collide, then there is a collision. And that's what I'm doing here. So here, this is it here. So they're the 6 axes there. And then here's the cross products. So here we're testing we're saying test 6 is equal to the cross product of the axis here with the axis here. And then we do that for all. So that with that, that with that, and so on. And then this with this, yeah. And then we're checking for overlaps. So if we go to the overlap on axis there, all that's doing is effectively what I was just showing. It's just checking along all the axes there. So for in I less than 15, so along the cross products of all those axes there, we're doing an overlap on axis check, and then getting intervals of the AABB and the OBB, and then returning so this is effectively saying, is there a collision? Well, is there an overlap on those? So as I was drawing, if there's this overlap here, so like if there's an overlap here, yes. So on this calculations, this would return true, but when it's doing its check along this axis, it would return false. And then, so that's the overlap on axis there. And then, so if one of them, if the result for that, it returns false. If any of them return false, then it will return false. That's it. So that's the AABB to OBB collision. I've still got a double AABB. Where is it? Yeah, here. This is straightforward. Like this is all that's needed for this, compared to the AABB to OBB calculation here. So this needs the overlap on axis check, which is this, which is getting the intervals, which is getting the interval of the OBB and getting the interval of the ABB. So ABB is straightforward. It's just getting the min and max values. So the get intervals is getting the vertices effectively. So it's easy to see in the AABB, because here we see it's the, let's say this is the bottom, this is the min x, so it's the left upper forward. So this is that vertex there. It's the left. If that makes sense to you, it's if you're looking at, if it's a cube, it's getting the top of the cube in the left. If you're looking from the top down, it's getting that top plane. It's getting the left top, and then this one's getting the left bottom. Yeah, but effectively these are the 8 corners, and then it's the same for the OBB and this here. So I'm just following the notation based on that book, but this is the corners with the based on the rotation as well, the orientation of the object itself as well. So that's what get interval does. Get interval gets the min and max of the vertices, and then we cast that in. We check in overlap on axis there, and then we detect if those overlap on axes actually collide in here. So that's all this. And this, I was doing this to, I was just testing itself, because as I said, when I implemented this, because I had, if I find it, where did I do it? I think in OBB itself. Yeah, I was actually, yeah, see here. So because I was doing create from your pitch roll here, because I thought that was what I needed to do, I was doing create, the orientation matrix for this was create from your pitch roll, but the model itself, I was doing where was it? I thought it was in this. Yeah, here, create. So here when I'm drawing it, I'm doing it based on create rotation X, create rotation Y, create rotation Z. So then all I had to do was just have that the exact same, and that was it. The oriented bounding box. What did I just do? Yeah, the oriented bounding box collision box is now exactly the same as the model render. So that's OBB. And if I didn't explain that the best, yeah, I'm sorry. It's just, I guess it's because my understanding of that is still limited. But I think with that drawing, it might help you understand the logic behind it, if that drawing was good enough. So yeah, they're the main things I've spent most of this week working on. So getting that camera class implemented, getting these methods in Collision. So as well, what I haven't done yet is OBB to OBB Collision, and that's actually straightforward with all this functionality already implemented. Instead of having these three axes as the axis align plane, you just have, so you would have OBB1 and OBB2, and then you would have this as OBB1 right up and forward, and then you would have these three as OBB2 right up and forward, and then you would get the cross products of those 3D axes there, and that's it. That's all you would have to do. So I may as well just write it now. I'll just show you. Is OBB to OBB collision. So just like this. You'll just do will be 1, 2, oops, 1, 1, 1, 2, 2, 2. And then this would be OBB1 axis 1, OBB1 axis 2. So you would just have, yeah, and that's it. And then you do overlap on axis check for OBB to OBB, which is just like this, and that's it. Because then all that's doing is doing this twice, one for the first OBB, one for the second OBB, whereas the ABB to OBB is doing the get interval AABB and OBB. Ah man, too many BBs there. So yeah, that's all for OBB to OBB. Hang on. If you're gonna I forget the word, but method duplicate or whatever, make sure that you're not using the exact same objects passed in, which is, yeah, these are two oriented bounding boxes anyway, and there. sure to change that. So if I might do that for next week, I'll show you the example of OBB to OBB collision there. But this will just check if the two rotated objects are colliding. So yeah, I'll do that for next week if I remember. Hopefully, I'll set up two planes close to each other and have them rotate, and then I'll just have it writable to screen so that you can see when it's colliding correctly. So that's it there. That's the logic behind it. So if you need me to go through the code again, yeah, here is just the get interval. Get interval for AABB and OBB is pretty much the same. You grab all the vertices, axis aligned. The vertices are really straightforward to get. You just get the mins and maxes. For the OBB, you need to get the vertices based on the position hearth widths in this along those vectors there. So here it's this. So this is, if you look here, we're passing in 3, right? 1, the X, Y, and Z, and that's just pretty much the same as this. So this is the X, but it's the X based on the axes of the object itself, that rotated axes. So this is the X, Y, Z of that rotated axes there. That's one vertex. So they're the 8 vertices of that. And then we just grab the min and max, which is the dot product of So here I'm just kind of doing the min and max is the same. It's just the minimum at the moment or whatever. And then here I'm getting the dot product of that vertex itself on the axis, and that's the projection. So if the projection is less than the minimum, then that's the new minimum. Same with the maximum. If the projection is greater than the maximum already calculated, then that's the maximum of the projection. And then return the projection result. So that's the intervals. And then when we're checking for overlap, we're comparing if those intervals intersect, or if there's if the minimum is less than, it's I guess you could say, yeah, it's checking if it's intersecting, but what it's doing is it's getting if the minimum is less than the maximum, and so if the minimum of the second object is less than the maximum of the first, and if the minimum of the first is less than the maximum of the second, if both those conditions are met, then an overlap has occurred, and returns true. So then with that, then you need to do that for every single axis. So you're doing it on the first 3 axes itself, as I showed, and then you're doing it. So that's the 6 axes check, and then you actually need to do it on the cross products of those axes as well, which I can't tell you why. I just read that book and it says you have to do the cross product check as well. So in the little paint drawing I was doing those 6 axes there. So if I didn't have these and I ran the overlap on axis check, it would check for collisions along those axes. But then I think, in a 3D space, I couldn't tell you why I'm doing cross products here, but it's necessary. So you just need to do it cross product of axis 1, which is the x-axis of the first object, cross product with the, let's say, the x-axis of the second, and then x cross product with the y of the second, x of the first cross product with the z of the second, and then the same for your y of the first, and so on. So if that's a better explanation, great, but I hope that's enough information to explain it well enough. And then, yeah, so here as well, I'm just wrapping. So here I would also include is OBB to OBB if I wanted this to be just an overall wrapper for all collisions, but this is the wrapper for check player to model. So what this is doing, it wraps whether, so this is, as I was saying, if the model is rotatable, then it's doing AABB to OBB. So if that model has the rotatable flag, then we know it's an OBB, so we're checking if the player is colliding with the OBB. But if it doesn't have the flag, the OBB isn't being calculated, it isn't being updated, so we check it against the collision box. Yeah, and then that test vertex was the thing I was just checking in those 8 vertices there. So that were the 2 main things I was focusing on. So again, I know this video is long, but it's mainly because I wanted it to be more of a tutorial. So as well, what I've implemented, this was yesterday, and I just started implementing it. I started with a gun and bullet, which is those cube objects. So here, instead of when I create a new bullet, I'll pass in the position and the rotation, but instead I won't pass it, it won't be a model object. So here you can see I'm creating a new model render for the bullet, and this could probably be for rockets. I'll probably use that for rockets, but for most of the bullets I'm just going to be doing rays, and then in collision I'll just do, there'll be new methods for is ray to OBB and is ray to AABB collision there. So where is it? Yeah, gun. This is the new gun class, which creates a list of fired bullets. At the moment, player only has 1 gun, but what I'm planning is player will, just like Battle Court, you will have your equipped gun, but I guess Battle Court has 4 equipped guns. What I'm going for with this, because I kind of figured out what I'm going to be making with this game, and it's you're going to have your inventory, you're going to have your equipped gun, you're going to have like armor, so you're like any ARPG. So it's going to be an ARPG game, and you're going to have like your equipped gun, everything, and that'll be changeable. So for now I've just got a gun. Nothing goes in the constructor for the gun, but when I have all that set up, then everything gets passed into the gun constructor for the starting, and then say you load a game, then it just loads in that gun object. So yeah, that's your equipped gun. So here the equipped gun contains a rotation as well, and I'm just updating that rotation, that rotation here, and the position, which is the same as your player position, which is the same as your camera position and rotation. If this was a third-person perspective game, gun rotation position can be the same as your player position and rotation, and then you might have like if you want to model it, let's say you might have it with a translation vector to your model, so it might be, you know, x to 2, y1, let's say, or in z2, so that'll make your gun position always at that translated. Yeah, sorry for the crappy explanation, but yeah, that'll, if you needed it to create bullets or whatever at a certain position. So yeah, for now I've just got it, as you see here, the rotation is based on your camera position and rotation, and then when it creates a bullet, it creates it. So here I've just got it creating a model render of that model path, which is the small cube you see there. I'm trying to find, because I've actually got it, where is it? Yeah, gun. No, bullet. So it must be, yeah, here. So here you're seeing I'm multiplying by 1.5f of the cam position target, and that is because if I go to player, you'll see I actually have. So if you look at this vector here, let's say there's a let's say radius of 1 around you. So when I do that multiplication by 1.5, I'm just making that circle a bit bigger. It's not actually that. It's in, I think, gameplay where I'm doing it for the camera itself, but it's pretty much this here, but for the 3 in 3 dimensions. So if I did this, right, say times that by 10, and then let's run this. I'll just switch to scene mode. That'll be smooth enough. The radius of the so the starting point for the bullet, see that? It's now a bigger circle. And yeah, I'm not doing draw order or anything on these bullets or anything, because this is just temporary. So that's why you're seeing, and that comes back to the model draw sort, which I was talking about in the first video, which is why I'm doing that sort, so that it draws the closer objects last, so that they appear on top of the other. So as you see here, I'm not doing the sort on these bullets, so I'm drawing these after this plane here, which is closest to me. So in reality, this plane should cover the draws of those bullets there, but because I'm not applying a sort, I'm just drawing them all after drawing the planes. You'll always see them. So yeah, nice big sphere there. But if I switched it back to 1.5, it'll set those starting points at 1.5. When it's raised, I won't even need to worry about having starting points or anything, because it'll just create from your position itself. But because I wanted to see the blocks and making sure they're being rotated correctly and everything, I was putting 1.5 there. So I'll just leave a black screen for you at the moment as I set this back to 1.5. And then, what's it doing? Yeah, window capture, there we go. So now that I've set it back to 1.5, that'll be a smaller sphere start there. So there. Pretty cool. You could make a 3D paint game out of it or something, but the performance cost of it, I mean, I am having it draw once every frame, so it's drawing a heap of bullets. So if I draw a heap here, watch that frame rate go right down. Make a little trail there. So frame rate, it drops a bit dramatically there, 40 frames now, and that's with 2,700 of those objects. And what I have at the moment, if they're 2,000 units away from you, so if you see it's at 100, and then when they get deleted, it jumps from 100 to 170. And then I'm just continuously falling now. And then if we jump, there's my little gravity direction fall. But yeah, I think other than those three things, that was it. I'll just quickly check the patch notes. Oh yeah, that's right. So I've converted the frustrum culling to use bounding spheres now. So I'll go into that quickly as well. Bounding frustrum, model frustrum view sphere, which is this now. And all this is a bounding sphere which gets the max half width, which is a return of your max between your width, height and length, and then just 3/4 of that. Because if I had, realistically you have it at half your width, height and length, but that will create a sphere which doesn't encompass the corners of your cube objects. I mean, realistically, what you do is you get the radius based on the max of your so it's your Pythagoras. It's Pythagoras theorem, I think. But let's say it was a 2D box, then you just want to get the hypotenuse of your width and length. But for 3Ds, you get the hypotenuse of your width, length, and height, and that's your radius. But yeah, I'm just lazily doing 3/4 of the max of your width, height, and length, and that works okay. So I'm doing bounding sphere because if I go back in the game, yeah, the wrong scene. Hang on. There we go. Yeah, half the time it's getting the video capture straight up when I switch. Half the time I have to do it manually. So what was happening with using collision box? So on these non-rotatables, it's okay. It's like, yep, collision box is in view. Okay, collision box no longer in view. Don't draw it. For here, it was using collision box as well, but I'm not using collision box for the rotatable objects. I'm using our interbounding box, and that intersects method that's inbuilt with X and A. You can't pass in your own custom models, your own custom collision stuff. So I'm just using bounding sphere. So because what was happening was, yeah, collision box is still that unrotated box, like that looks like that. And then as you look underneath it, so when you're from this angle, it's like, oh yeah, collision box is no longer in view, so don't draw it. So like on these ones here, it would stop drawing it when it was like that. See that top? So that top rotating box just there, because that's not in the collision box, it wasn't drawing it. So yeah, I didn't want that. So I switched it to bounding sphere. Ideally, I was wanting to do intersects on my OBB for the rotated, but yeah, this is a one that comes with XNA here, and you can only pass in. I mean, I could possibly add to this, but I don't want to. But yeah, this is the pre-built XNA MonoGame intersects method there that I'm using, and that's it. It's just still the same. View, multiply by projection, detect if that intersects with your object. So that's it. Oh, I spent a bit more time in this video going through the code. I'm not sure how long this video has gone for, and I've actually done this video so many times because I wasn't happy with how I was explaining things, and I was like, yeah, I'm not explaining things well, let's restart the video. And that was like 17 minutes into that recording, and so I think it feels like this has gone for an hour, I don't know. But that's everything I've worked on this week. I kind of went more in depth on the code to give more of a tutorial. Kind of talked about the plan of what I'm going to do with this game, and I'm going to make an ARPG. I guess I'll bring it, like I can bring in a lot of the stuff I've already done for Battle Court, so the looting system for the weapons, and then I can make that for armors and everything. And then the world space itself, I'm thinking open world, but I really want, like, I guess what I have in my mind is something, if you ever played the second Elder Scrolls, like a real open world dungeon explorer, not as massive obviously as the Elder Scrolls Arena, but something that has that same feeling of depth and exploration, and then like a leveling system that feels like it has no limit, so it doesn't end at level 99 or whatever. It just keeps going, so that yeah, you just feel like you keep progressing. And I guess some of the concepts I want to bring in from, if you've ever played incremental games, and that feeling of, even though you've gained a heap of resources, let's say, there's always more, and your resource gain increases exponentially. So as you've played it for 80 hours or so, you've already gained, 20 billion resources, let's say, and then to go from, it takes you not long to go from 20 billion to 21 billion at the late game. So it has this exponential curve of continuous growth, and then your targets, your target for your next, your next gameplay target is, I just want to get to, 21 billion. I just want to get, so kind of like along the lines of that feeling. So those concepts in incrementals combined with ARPG. So, you've played the game for 40 hours, you feel like a powerhouse, and you're rightfully so. You've invested so many hours in building your character, but then the further, let's say it's dungeons in the game, the further deeper you go, the enemies increase exponentially, and your next target is, I'm a powerhouse, but these enemies are hard too. And yeah, that's kind of the concept I want to apply to this game as well, in an ARPG environment. So really have exploration, really have open worlds, and yeah, I guess as I build this game, I can keep working on what I can do and what I can't. But I really want to make this game fun. And I guess that was the plan with Battle Court in the first place. I wanted it to become a real open world ARPG and expand on that looting system But yeah, I guess now that I'm learning 3D, I'll leave Battlecourt as is, and updates will be relevant to what that game is, as a little arcade survival looter shooter, and then make this second game a real big open world type ARPG with those same looting concepts. But yeah, we'll see where this goes. But I guess as well, implementing something like that, the incrementals and the concepts behind it, it might feel repetitive after a while. So that's probably the biggest thing to tackle, is to make it not feel repetitive, always feel like there's progression, and make the progression interesting. And I know, like, adding unique environments as you progress, newer enemies, new weapon effects and all that helps to prevent that. But I really want to think about that more, and have concepts that prevent that repetitiveness. And always want the player to feel like they're exploring and everything. But yeah, so that's the plan with this engine. And these videos, the plan is to keep talking about what I'm working on in tutorial form. So yeah, they're going to be long, I guess. But, you know, it doesn't really matter because, well, last video was 30 minutes. This one, I don't know how long this has gone for. But for anyone interested anyway, it might be a good video for you. So, oh yeah, there we go. I can see recorded. Oh geez, yeah, an hour, 10 minutes. So I guess that's it. I'll leave this video at that. This has been a very long video. I hope it's been interesting and has kept you interested for this hour. No, can't blame you if it hasn't. But yeah, thanks guys for watching, and I'll see you in the next video.